So in this video, we're going to look at how we're going to perform the interval estimation. So what is interval estimation? So interval estimation has two different kinds. So one is called a confidence interval. So that is the interval estimated of the mean value of y for a given value of x. So another interval estimation is called the prediction interval. So that is used whenever we want to predict individual value of y for a new observation according to a given value of x. So what does that mean? So always keep in mind that if we go back to the previous example, so we are asking for if an employer worked for the firm for 10 years, so how many share of the stock they own. And then after we calculate the point estimation estimated, and we got 431. So the question is, if you go to the company to interview an employee who worked for the firm for 10 years, do you think the answer always be 431? The answer is no. So what we are trying to estimate in the point estimation is on the average value. So the average value. So which means there is uncertainty involving in this estimation. So how can we capture in this uncertainty? So what we are doing is called calculating this potential range. So what will be the range? So why we have two different kind of range? So one range, the confidence interval. So we are trying to calculate on average what will be the possible range. So what's the possible range for the average? And the second interval called the prediction interval. That is, we'll pick one person out. We'll just try to predict that specific person. So what will be the possible range? So that's why we have the two different kind of intervals. So in order to calculate this kind of two intervals, you have to remember we actually have to go through two steps to calculate this interval. So next I will show you how to using the what kind of formula we're going to use to calculate these two intervals. So first, we're going to look at how we're going to calculate the confidence interval for mean of y. So the step number one, we need to calculate the estimated standard deviation. So estimated standard deviation. And so first of all, the estimated standard deviation equal to S is a standard error. And so in the computer skill 4, we will be able to learn how to find this value from the Excel outputs. So make sure you're going to watch the computer skill 4. So the next video following this video. So make sure you're going to watch that one, because that one is literally tell you where to find S. So the standard error times square root 1 divided by n is the sample size plus the x star. So the x star is the value you will be given from the question. So it will be given from the specific question, and the minus x bar. So what is x bar? So we learned this notation in chapter 3, numeric distribution. So that actually is the mean of x, and then square divided by n minus 1 times s squared x. So we learned the notation s squared before. That is called a variance, sample variance. So the reason we have the subscript x is because when we look at the simple linear regression model, we have x variable and y variable. So here they try to emphasize that this sample variance is for x variable, it's not for y variable. So after you follow this equation to calculate the estimated standard deviation of the mean of y, and then we're going to using this value. So then we're going to using this value s squared x to finish our second step. So step number 2, it is the final step we need to go through to calculate the confidence interval for mean of y. So first of all, the y hat star. So what is the y hat star? So actually we saw this notation before. Let me go back to the last video. So you can see we actually see the y hat star before. So the y hat star means the point estimation. So the point estimate. So we are using the point estimate to construct the confidence interval. So the point estimate minus t. So t is the t statistics. So if you already watch our computer skill 4 video, so I move myself a little bit so I don't block. So if you already watched the computer skill 4 video, you know that the t statistic can be calculated using Excel. The formula we're using is a TIMV. Alpha is always equal to 0.05. So alpha always equal to 0.05. And the degree of freedom of residual you can find from the Excel output. So this formula, Excel formula, allow you to calculate the t statistic value and then multiply by sy hat star, so which is the what you got from the step number 1. So the lower boundary of this confidence interval is y hat star minus t statistics times sy hat star. And the upper limits is using so here there is a typo. I will change it. So here should be plus. So y hat star plus t statistic times sy hat star. You calculate in the step number 1. So that is how you calculate the confidence interval, the lower and upper boundary. So this is a confidence interval. So now let's look at the next is the prediction interval. So in order to calculate the prediction interval for individual y, we still go through the 2 steps, very similar 2 steps. The first step, we calculate the estimated standard deviation of individual y. And so look at this, we are using a little bit different notation. Instead of using sy hat star, we use s prediction equal to s times square root 1 plus 1 over n, and the plus x star minus x bar square minus n minus 1 divided by n minus 1 times standard sample variance of x. So now if you look at step number 1 of the prediction interval, actually it looks very similar as our confidence interval, right? Let me go back to show you the confidence interval. So this is the step number 1 for confidence interval. Did you notice the difference? Yes, you can very quickly find a difference, right? So the confidence interval doesn't have that actual 1 inside square root. If you look at the prediction interval, so you have this actual 1 inside the square root. So that's the main difference between confidence interval and prediction interval regarding the calculation. And the step number 2 are the same. So since the S prediction is different from the S confidence interval sy hat star, so that's why your prediction interval will have different value compared with your confidence interval. But you can see the connection between these 2 intervals. So keep in mind. So now let's look at the example together. And so I will fix this typo here. So here should be plus. Let me just do it here. So here should be plus. So we are using the same case. We look at this worker who worked for the firm for 10 years. And what is the, instead of calculating point estimation, we look at the 95% confidence interval for their mean shareholding. So we are predicting the range for the mean value. So that's why we're using the confidence intervals formula to do the calculation. So y hat star minus t stats times sy hat star. So the sy hat star equal to this formula. So if you already watched the computer skill 4 videos, and then you will be able to know how to obtain the values. So first of all, let me go back. So the y hat star we already calculated in last video, right? So let me go back to, if we go back, so this is the y hat star we calculate. So 431.87. So it's pretty straightforward. And then the second is based on the formula. We need to use the value for the n, the sample size, and x star. So like I said, I just mentioned x star is the value will be given to you in the question. So here we talk about the employee who worked for the firm for 10 years. So the value for x star equal to 10. So when you watch this video, I really want you to write it down. Please don't just watch it, because there is so many information. If you can write it down. So the x stars value equal to 10. X star value equal to 10. And the minus the mean of x. So the mean of x. So where's the mean of x? So that is in the computer skill 4, we mentioned that in order to get the mean of x, you need to use the skill we learned in chapter 3. The discrete statistics to developing this discrete statistic for x variable. So now you can see the mean of x is equal to 10.5. So this table, again, make sure you are fully using your handout as well. The handout called the chapter 14 handout because you can see that table in the second page. So that is the discrete statistics. So the mean of x, x bar. So this one is the value for x bar, right? X bar. And so let's go back, see what are the value we need in order to do the calculation. So we also need the value for the sample variance of x, right? Sample variance. So we have the value for x star equal to 10, and x bar is mean of x. And we also need the x squared x. So that is from your second table. It is called the sample variance for x. So sample variance for x. So here is the value for x squared x, right? So we have the x bar, x squared x. So we're going to see what other thing we need. And also we need the value for, we also need the value for n. So where is the value for n? And also where is the value for s? Standard error. So in order to find the value for standard error, what we need to rely on is on your chapter 14 handout, the first page, the regression output. So you always can find the standard error in the first table called the regression statistic, and corresponding to this value called standard error. So that is where you'll find the value for S. So 91.4789. So that is value for S. And then we also need the N, the sample size. So which is under the standard error, we have the one item is called observation. So that is where you find the value for N. So S and N. So now we have almost all the values. So first of all, we already estimate a point estimate. And the second, in order to calculate S, Y hat star, our first step, we already know where to find S, where to have the value for N, where to have a value for mean of Y, X, where to find the value of sample variance of X. So the only thing we don't know is our T statistic, right? T statistics. But if you go back to a few slides, so the T statistic equal to, you can use the Excel to calculate TINV, alpha, which is 0.05, DF residual. So the only thing you don't know in this formula is the DF residual. So where is the DF residual? So the DF residual is under your regression output. So DF, you see the second table, ANOVA table, you have DF, and you have residual, so the degree freedom of residual. So that is the second entry of that formula. So then if you're using that formula, you will be able to obtain the value for T. So basically, you have every symbol's value. What you need to do is just plug in everything to this equation to calculate the final answer. So let's see how we do the calculation. So basically, we have all the values we need. So all the value we need. So we follow the two steps to do the calculation. First, we estimate the standard deviation of the mean of y, and then we obtain 32.7164. And then we using this value in the second step, and then finally we calculate the value. So the 95% confidence interval is between 351 to 511. So how you interpret this result? So interpretation, based on our calculation, we have 95% confidence to believe that the mean number of shares for persons working for the firm 10 years will be between 351.82 and 511.93 shares. And so this is the calculation for the confidence interval. How about the prediction interval? So the prediction interval is very straightforward. So everything is the same except when you do the calculation for your first step, and you need to add in this actual one inside your square root. So let's see how we do the calculation. Like I said, basically everything is the same, except when we do the calculation in step number 1, we have this actual 1 inside the square root. And then that is what we got, 194 to 669. So that is what we got here. And so to interpret our result, we would have 95% confident that the number of shares an employee working for the firm 10 years will be between 194.14 to 669.61 shares. So that is how we interpret the prediction interval. So that's the end of this. That is the end of the chapter 14 part B. And as I said, in terms of calculation, make sure you're going to watch the computer skill 4. So the video you should watch is called how to use Excel to calculate confidence interval for mean of Y and prediction interval of individual Y.